So let's say you're walking down the street one day and somebody says, hey, what is the molar mass of phosphoric acid? Well, first thing you're going to need to know is the formula for phosphoric acid, so I'm here to help you out. So this compound, I'm just going to show you real quick basically how to read the periodic table to determine molar masses. It's actually pretty simple. The reason you need to know to do this, like I said in a previous video, you need to know how to use that number to calculate usually the number of moles and kind of go both ways on that, grams to moles to grams. That's going to be addressed in another video lecture. But here, this is just how to figure out how many how many grams are in exactly 1 mole of something. So the first thing you're going to do is you're going to grab the ultimate cheat sheet in the universe, which we know is the periodic table, and we're going to look up the atomic masses of all of these different elements. And what we're going to do is we're going to plug it in to the following calculation. We are going to take 3 times whatever the atomic mass of hydrogen is, and then we're going to add that to 1 times the atomic mass of phosphorus, and then we're going to add 4 times the atomic mass of oxygen. Add all of that up on your handy dandy pocket calculator. I literally have a calculator in my pocket. That's how cool I am. And we're going to figure out how many grams that is, and that'll be the number of grams in exactly 1 mole of this thing. So pause for just a second. Okay, so I looked up those atomic masses, and these are the numbers that I came up with. Keep in mind, I'm rounding them to the nearest hundredths place. And so if you're using the full-on value, don't be surprised if your answer differs just a little bit from mine. So, right, keep in mind 3 times that number, right, because we've got 3 hydrogens, 1 times that number, because that's the atomic mass of phosphorus, and 4 times that number, which is the atomic mass of oxygen. I add all that up, and I ended up with, hopefully I didn't screw anything up, the fact that exactly 1 mole of that H3PO4 is equal to 98 grams. Right? And so one of the things I wanted to kind of develop here is that idea of like a sniffer. So keep in mind, right, when we start doing our calculations with these numbers, that if I'm like asking you to, let's say, give me 10 moles of something, right? You should end up with, kind of a scalable amount, right? So like 10 moles of this, I can just move a decimal point and recognize that I end up with 980 grams, right? And so let this number kind of like orient whether or not you're doing a lot of these calculations right. You really do kind of have to sniff the values again to make sure that you're ending up with the right calculation, right? If you were to see like somebody said, hey, I need 10 moles of this, and you did a calculation and you discovered that you needed like 0.003 grams or something, you'd be like, yeah, that ain't right, because I know in 1 mole of this is 98 grams. So let's try one more, and then we'll see how we're going to use those numbers. And I should mention, and hopefully apparent down here somewhere, I did include a resource guide for today's lecture having to do with molar masses. And there's also kind of an accompanying sheet that takes those molar masses and asks you to do some kind of gram to mole and mole to gram conversions that we'll be doing in the next video lecture. Let's try one that's a little bit harder. This one's a little bit farther down that resource guide. I think it's like number 8 or something. And what you'll notice is this big giant polyatomic ion here. And one of the things that might help you to remember is that subscript 4 tells me that whatever is inside of these parentheses are taking 4 times. So let's see what this thing looks like when I kind of list out the numbers that I'm going to use. So here's the calculation I'm going to be doing. Keep in mind, we've got 1 times the atomic mass of lead, right? Because there's only 1 lead in there. That 4 is talking about what's inside of the parentheses, and lead is outside the parentheses. So there's a 1. I'm going to use 8 for the atomic mass of carbon because inside of those parentheses, I've got 2 carbons listed out, times 4 for the total of 8. I'm going to do 12 times the atomic mass of hydrogen. 3 times 4 is 12. And then 8 times the atomic mass of oxygen because I've got 2 there. And if I've got 4 groups of 2, that's also 8. So that's what I'm going to plug in. I'll show you all the values, and then we'll see what we end up with. There are all the values, the atomic mass values of each one of these individual elements. And when I enter that into my calculator, what did I end up with? 371.34. 371.34 grams per mole. So if I have this big, ugly, delicious tasting substance right here, if I wanted 1 mole, it should be around 371 grams. So hopefully this gave you some insight into how to do these calculations. Really is as simple as multiplying and adding. And then we're going to see how a dimensional analysis can help us to actually use some of these numbers.